Good evening, guys. So today we are going to start with Raspberry Pi. Okay. So this Raspberry Pi is a kind of operating system. Okay. So before we are starting with the session, I just want to be clear about see this Raspberry Pi. We need a board, and the board needs to connect with one monitor, and then I can develop a code in my Raspberry Pi. So when I am doing all those things, you can able to get some idea about how Raspberry Pi is completely working as a hardware. So as we can't able to handle the Raspberry Pi for this meeting kind of things, so what we are doing is we are actually starting with the visualized kind of thing. Okay, so I will share one video how the Raspberry Pi work, and how the Raspberry Pi board is there, and how Raspberry Pi is working. Then I will execute the Raspberry Pi code in my Python IDLE itself, so you guys will get some idea about how to write a Raspberry Pi code in Python. Okay, so first we are starting with Raspberry Pi. So this is an official website of Raspberry Pi. So www.raspberrypi.org is the official website. So we have a lot of projects in your Raspberry Pi. Before we are starting with Raspberry Pi, the very first thing you guys need to understand is your Raspberry Pi is a kind of board which is used to handle a system kind of thing. Okay, so simply telling, Raspberry Pi is a mini board, kind of motherboard. Okay, so you can't able to deal with any of the things like Arduino. We can't able to deal with Raspberry Pi. Okay, so when you are handling one system, you need one monitor, you need one keyboard, you need one mouse. So those kind of setups are needed for Raspberry Pi as well. Okay, so the Raspberry Pi is a kind of simple board which is used to handle all kind of task. So this is your Raspberry Pi. So this is how the Raspberry Pi looks like. So this is a model B. Okay, so see, in this model, when we are having some processor. Okay, so this is an actual processor. So this is actual processor. So this is a RAM speed. So you can able to choose a RAM speed from 2 GB to 8 GB. So depends on the RAM speed, your Raspberry Pi cost will also change. And here you are having a USB-C power supply. This is for power supply. This is USB-C type. And this is for it's a micro HDMI port. This is HDMI port only, but this is a micro HDMI port, so which is mainly used to connect with monitors, because monitors are used to connect with the HDMI port only. And this is also power jacket. So when it comes to this part, so this is, and this two thing is mainly used to connect the camera peripherals. And then this all USB, and this is to connect with Ethernet, but there is no need of Ethernet because your Raspberry Pi comes with Wi-Fi, Bluetooth capability. And this pins, so all these pins, so all these pins are mainly used to connect with input output. So these pins are used called as the GPIO, general purpose input output pins. So you can able to make your input output with the help of these pins. So this is how your Raspberry Pi works, looks like. So in this Raspberry Pi, it's exactly act like your system motherboard. Okay, so you need to load one software to this Raspberry Pi. Software, that's nothing but an operating system. You need to load an operating system to the Raspberry Pi. So Raspberry Pi, it can be able to access all the elements. So this is how you can able to deal with Raspberry Pi. Okay, so this is a basic introduction. So when you are going for downloads, you can't able to get any software. You can able to get only operating system. Okay, previously it was called as a Raspbian. Now we are just calling as a Raspberry Pi OS only. So this is an official OS for Raspberry Pi boards. We have a two kind of Raspberry Pi OS. One is Raspberry Pi OS, another one is this knobs. So what we'll do is both looks same. So you can able to download any of the thing. Apart from, you can able to download the desktop Raspberry Pi as well. Apart from, you can able to go with Ubuntu or OS, and then any kind of Linux, and then even you can able to go with Windows IoT OS. So Windows IoT OS also there. Normal our Windows 10 also we can able to load with the Raspberry Pi. So when we are going for even Raspberry Pi official website, when you are going for your normal download, we won't get any kind of software, we will get only the OS. So the very first thing is, I just want you guys to understand, Raspberry Pi is a board which is exactly act like a motherboard. And when you are going to deal with Raspberry Pi, you are just going to deal with one operating system. Okay, so the how the operating system works and how the Raspberry Pi even works, let me share one more screen. So see, we need to go to downloads, and then we need to download the things. So this all stuff now I explained to you guys. So after you download, this is how the Raspberry Pi works. Like, you need to extract the things. After you extracted the things, you need to boot this like normal operating system. How we will change the operating system, we need to boot that. So after you booted this, simply copying and pasting to the SD card. Okay, so simply copying and pasting to the SD card, so it will load the operating system in your SD card. So here you can able to deal everything with the help of SD card only. You can't able to deal with anything else, because in a Raspberry Pi backside we used to have one SD card slot. That SD card slot will act like your ROM. So you need to give any minimum 8 GB of SD card. It's mandatory, but you can go for 64, even 128. It's all up to you guys. Because when you are giving the SD card, that SD card will act like your system local disk. Okay, so we have a system local disk C, D, E. The same kind of the local disk kind of things you can able to deal with only the SD card. Because Raspberry Pi will comes with only input output pin, and it will come with processor. It will come with communication stuffs enabled, but it won't come with the normal thing. Okay, so after it pasted in the normal SD card, we need to remove, just we are just removing the SD card reader from the system. After we remove, this is the HD, this is your Raspberry Pi. So in the back side we have this SD card slot. So we need to insert the SD card slot to this we need to insert the SD card to this SD card slot. So once you insert it, now you will come up with the stuff which is nothing but your Raspberry Pi is inserted to your Raspberry Pi is comes with your normal local disk. Okay, so if you are coming with the normal local disk, then only you can able to handle the OS kind of things. If you are not dealing with anything, okay, so if you are not dealing with this SD card kind of things, what will happen? No, you can't able to get the things to be done. Okay, you can't able to load OS, or you can't able to load any of the things. So SD card is mandatory for us. So when you are going with your the next thing, see here, this is how your Raspberry Pi OS will looks like. So your Raspberry Pi OS will extract the things like this. So once you are connected with Raspberry Pi, you need to connect your Raspberry Pi with the help of HDMI to some monitor. It may be a TV monitor, or it may be your system monitor. You can able to do anything. But when you are loading the things, no, it will ask some kind of it will do setups like the same kind of thing. So after your OS is set up now, so what it will do is it will start with your normal stuff. Okay, like our normal Windows, normal things, your Raspberry Pi will start to deal with it. So in the Raspberry Pi, again, you guys needs to open any Python IDLE or any other Sublime Tester or Visual Studio Code or Anaconda. So you can use any Python IDLE. Not only Python IDLE, you can use any other IDLEs and you guys can easily deal with the things. Okay. So your Raspberry Pi, when you are running a Raspberry Pi OS itself, what will happen now? Your Raspberry Pi, by default, it will load your Python. No need of even installing Python, because Raspberry Pi will be preloaded with Python. But now we are not dealing with our Raspberry Pi. We are dealing with the normal Python IDLE. So we could not able to run the things. So I will just to go ahead with the normal LED printing, LED blinking, and a normal sensor connectivity, and how the chatbot we can able to develop with the help of Raspberry Pi only. Okay, because we could not able to make work, because we need a Raspberry Pi board. I will explain in depth. See, when I'm just going for writing the code, once you set up your Raspberry Pi OS and all those things, we will get a Raspberry Pi Python inbuilt in your Raspberry Pi. Okay, so I hope you guys are already having an idea about Python. So I'm just starting import. Then RPI. RPI, that is nothing but a library which is compatible with only Raspberry Pi board. You can't able to use this RPI in your normal system. Okay, so now we are executing in normal system only. We could not able to achieve the things. We need to connect this RPI only with your Raspberry Pi. The reason is from RPI using GPIO. GPIO means general purpose input output. When it comes to your general purpose input output, we need that pins also. The general purpose input output times also we need that. So for that perspective, it will run only in Raspberry Pi. So I am importing your RPA and GPIO in the name of GPIO. Okay, so I hope this all basic Python syntax only. I hope you guys are aware of this importers and all those things. Then I am just going to get time library. So this time library is mainly used to give a delay. So this is basic Python library only, not IoT based things. So now after this, I hope you guys may aware of how to handle the inbuilt functions in Python. Because when you are dealing with Python, Python is 100% based on inbuilt functions, correct? So we do have whatever you are choosing for Python, so that is a completely based on inbuilt functions only. Okay, so when we are going for your Raspberry Pi or this time and all those things, we will be going to deal 100% with the inbuilt functions only. So here also GPIO. So this GPIO, what I'm just doing here is I am just going to set the warnings. So set warnings, why I am using a set warning means if there is any warnings or if there is any deprecated error. So deprecated error means some of the Python functions will be removed in the future. So if there is any kind of warnings is there, I want to make that as a false. I don't want to get any warnings when I'm running my Raspberry Pi. So I'm just making as a false. Then I need to use set mode. So the set mode is mainly used to give physical pins. Okay, so what kind of physical pin I'm just going to use, that's what my set mode is. So first what I need to do is GPIO. So GPIO, that is nothing but my Raspberry Pi general purpose input output, and I'm just using my set mode. So in this set mode, I'm just setting my own board. Okay, so own board, that is nothing but my Raspberry Pi board. Okay. So after this, I'm just going to set up the thing. So what I'm just going to set up here is GPIO dot setup. So what I'm just going to set up is in a 8th pin, I'm just going to give a output. So output, that is nothing but my LED. Probably here we are just discussing about LED printing only. So in 8th pin, I am connecting my LED and initial. So initial, that's nothing but the initial stage of my LED, that's nothing but low. So low, you guys are aware of, that's nothing but 0. So I am just setting up 8th pin, my LED output, and comma initial, that is nothing but once my Raspberry Pi on, my LED used to be low only, that's nothing but my LED value 0 only. So after this things, once this thing set up now, I need to go for a while is a keyword. Okay, so you guys know while loop, I'm just giving a true. So when I am giving a while true, it will run forever. So it's running forever means it is going to run every time. There is no end for this, because the reason is while true. Until you are making this while loop false, it will keep on running the loop. So here I am making while true. So it will automatically enter into my while loop. So I'm just giving a GPIO, that's nothing but my general purpose input output. Then I'm giving an output. So in this output, I'm just giving 8 comma GPIO high. So that's nothing but my general purpose input output will be high. So the next thing is, I'm just going ahead with sleep 1. So sleep 1 means 1 second delay. So when I'm giving an 1 second delay, so what it will do is, it will make my high value, that is nothing but my output is 1. So that's nothing but my LED will be on and it will be stay there for 1 second. Then again GPIO dot output. So my output in 8th pin, and this is going to be low now. Low means low, 0 value. Then sleep 1. So that's nothing but for another 1 second it's going to be low. So now what we are actually doing here is LED on off on off on off. So when I am just running this code, now I'm not going to get any output, because I'm not running in a Python ideally. I'm not running in a Raspberry Pi. I'm running only in a Python ideally. So I can't able to achieve the thing. So here I'm getting a no module name RPA. RPA means Raspberry Pi. This RPA module is compatible with only Raspberry Pi board. So once you develop the code in Raspberry Pi, what we need to do here is, once we developed the code, next step, you need to assemble the circuit. After you assemble the circuit, you need to open your command prompt in a Raspberry Pi. Okay, then you need to change the directory where your file is there. So my file is in my downloads. So after I change it to downloads, I can simply give Python sample. So yeah, so I'm getting a module not found error, because I'm here, I don't have a RPA module, so I'm just getting a module not found error. Okay, so like this, running writing a code, everything is same, but when it comes to your output setup, we need to connect your Raspberry Pi board along with your monitor. So then only you can able to come to know this exact output. The reason being is, when I am running this Python file in a Raspberry Pi board, it will automatically starts to work. So for example, when you are switching on your system, on off. So when I am pressing my button here, on button, so my system is getting on. So how it's getting on, my Windows is loading. After my Windows loaded, I'm getting a login. So you need to give your password. After you give enter, it is redirecting and your system is getting on. The same, when I am touching my button, some of the software is loading in the backend. The same kind of thing, your Raspberry Pi board will work along with the code, and it will work only on the Raspberry Pi board. That's how your system motherboard is working with our laptop. The same kind of thing will be executing in a Raspberry Pi. So the reason we are going ahead with Raspberry Pi is it's exactly like your laptop, or exactly like your system now. So once you connected with the sensor, okay, so you can able to once you switch on the device, automatically you can able to make the code to be run. So once it starts to run, it will keep on emitting the result for us, not like Arduino and all those things. So Arduino is a microcontroller board, but your Raspberry Pi is a kind of motherboard. Okay. So Arduino is having separate IDE. So for example, you need to go with Arduino ideally, and you need to use Arduino C or Python. So that limitation is there. But when it comes to Raspberry Pi, we have an unlimited programming package. Okay, we have an unlimited IDEs. So you can install whatever IDE you want to install, and you can able to handle the things whatever you want to handle. Okay, so like this we can able to handle with the help of our Raspberry Pi. So the next concept is your Raspberry Pi will comes with inbuilt camera peripherals. So making an image analytics, working on image based data set, Raspberry Pi is more easier for us. So the next thing is making a voice interaction robot. Raspberry Pi will be more helpful. The reason being is clock speed, RAM speed, and ROM. We can able to choose how much we want. But Arduino, your clock speed also low, and your RAM is only 2 KB. Okay, so which is very less. But here you can able to go for 2 GB, 4 GB, 6 GB. Now we are coming ahead with even 8 GB as well. So when we are going for 8 GB Raspberry Pi board, all it will works much better than 2 GB. But as you guys are for studying purpose, 2 GB is more than enough, because you are not going to handle the high loaded. So only handling 2 GB board is more than enough. But when you want to, so one single mobile, that mobile is working, so when you are touching the sensor, it actually starts to work. So in this mobile you need a processor. So in the same processor it will be connecting with the GPIO and all those things. So GPIO nothing but input output pins. So when you are touching the screen, or we used to have a sensor in the backside of our phone. So when I'm touching it, the sensor starts to work. The same kind of setup we can able to achieve with the help of Raspberry Pi only. We can't able to achieve with the other things. So that's the reason we are choosing a Raspberry Pi or Banana Pi or Onion Pi instead of other boards. But the problem here in Raspberry Pi is costlier. It's very costlier. So for 2 GB itself, the original board costs around 5,000. Then you need to get the Raspberry Pi shield, and then sensor, and then camera peripherals, everything. So to do some basic mini project in Raspberry Pi, we need to spend around 8 to 10K. When you are going for advanced level of Raspberry Pi, then you need to go with your 8 GB and all those things. That is little more costlier. So for that perspective only, people who are starting their career in IoT, they will start to work only with Arduino. But Arduino is a only microcontroller board. Raspberry Pi is an operating system board. So we need to load one OS with the help of some ROM. So then it will be loaded in your system, like how our laptop works. Then you can able to connect the sensor with the help of GPIO pins. Then we need to run the file in a Raspberry Pi board, which is connected through the monitor, so you can able to type and you can able to access the element. So all the outputs we can able to get when you are running in your Raspberry Pi board only. As of now, you guys can understand how to write a code for Raspberry Pi. Okay, so this is the basic introduction about Raspberry Pi, and this is how Raspberry Pi will works here. So you guys having any doubts? See the pin utilization as GPIO I or 1 you are giving here. Actually, I'm not getting your question. Pin utilization. We need to set a pin utilization, because here I give a 8 and here I give a GPIO out. That's nothing but output pin is 8. So then where there is, if this is a Raspberry Pi, So here we may have a processor, then here we have a camera peripherals, and here we have a lot of pins. So in this pin, the eighth pin, I am going to connect my LED. So my LED positive will be connected here, and we do have a ground pin also. So this ground will be connected to LED ground. So like this, we can able to deal with this. Of course, we do have a pin utilization as well, but that pin utilization or we need to set up here. That's the concept. So any other questions? Okay. So the next thing is, when you are going for a Raspberry Pi, you can able to set up any kind of input output. Okay. So when I am going ahead with the LED, so simply what we did here is, we simply did set mode GPIO board. So this is a kind of default one. So in case if I want to deal with some kind of when we want to go for push button or something else. Okay, so when we are going for push button or some other kind of output, what we can do here is, so this GPIO setup the same pin number. So now I am going for an input. Okay, so let me comment this line. So let me just get the another line. So GPIO dot setup. So I am just telling how to set up the input output. I'm just using the same eighth pin. Okay. So after this, either that button is an input or output. So what I'm just going to do is a GPIO dot in. Dot in. So that's nothing but eighth pin is now input. So what's your input that I want to tell? Initial, previously I give one initial. This is a keyword argument in your Raspberry Pi. So then I just give a GPIO low. That's nothing but I'm just making my general purpose input output as a low. Uh, Now I am going to deal with push button. So for to deal with push button, what I can just given here is pull underscore up underscore down equal. I need to tell this is a push button. So for that perspective, what I'm just going to do here is GPIO dot push button. No? So this is an inbuilt function for push button. So after I set up this, I can able to achieve the things. So simply telling when I am just dealing with push button, this is an inbuilt function which I need to deal with. Okay. So the next thing is, I don't need a while loop now. So when the push button is pressed, I want to do some function. Okay, so when it comes to function, we will be dealing with a lot of functions. So I hope you guys are aware of defining function and all those things in your Python. So define main, so that's nothing but my function name. So here I am just going to give some print statement. So let me give button is pressed like this. So in this main function, what we need to do here is, see, you guys needs to make a visualize kind of things. Okay. So what I can able to do here is, when my button is pressed, I need to call my function. Okay. So for that perspective, we have another function like GPIO dot add underscore event underscore detect. Okay, so now what it will do is, it will detect your button press in eighth pin, and what it will do is, it will rise some GPIO. So rise means it's going to rise some function. Okay, so then I need to call my main. So main, that is nothing but the function. So when the button is pressed in my console, I will get button is pressed kind of alert message. Okay, so this kind of functions and this kind of function callings are very easier when we are going ahead with Python. But when you are going ahead with the other programming language or something, we could not able to get this much of things. Okay, so simply calling the functions and everything is easier in Python. So that's the reason we'll be going ahead with your Raspberry Pi. Okay, so you guys having some doubts? See, we have total 30 pins in Raspberry Pi. GPIO pins, total we have a 30 pins. Any limit for minimum maximum number of pins? See, actually, when it comes to the minimum maximum number of pins, in the 30 pins, I guess we will get around 3 to 4 pins for voltage, positive, and 2 to 5, more than 3, 4 is actually for ground. And then one is for receiver, another one is for transmitter. This is the common thing which we will get in all the boards. Apart from, I guess we do have only 18, around 20 something pin only we will get for GPIO purpose. So in this 20, we can able to give number of input and number of output. Okay, so that's the concept. So we don't have any limit for minimum and maximum number of pins, but when it comes to your GPIO pins, we are having almost 20 around only. So when you want to connect your input output, you can able to handle only the 20 amount of things. The same, we don't have any limitation. But the problem in this Raspberry Pi is when you are writing code in Python, you need to make multi-threading kind of things. So multi-threading means in a single time you are just going to make a multiple functions to run at a time. So that's what the multi-threading is. So you can connect the number of pins. That's all up to you. So in a time, at a time, if you want to run more than one function means, then you guys needs to utilize the multi-threading concept for writing a code. So then it will starts to works fine. Okay. So the same thing only. So any other questions? Okay. So I guess you guys are okay with this basic LED and the basic output things. Now let's we go for ultrasonic again. See, when you are going for an ultrasonic sensor, I hope you guys are already aware of how the sensor all work. Now let's we see how to write a code for ultrasonic. The same thing only, no need of function. See, I will be telling you in Python, whenever something is pressed, okay, so if button is clicked or button is pressed or some fingerprint sensor is start to work or camera detected the image, or then what else we can tell is the particular distance, the movement of the distance. So if we got some kind of conditions like this, we can able to trigger the function. Okay, so triggering the function is also very important in Python. So when you want to trigger the function, so you can't able to all the time, you can't able to trigger the function. So you in only in some particular situations only we can able to trigger the function. So those kind of situations are mostly known as event handling. So when you are handling the event, we used to add this inbuilt function and we used to call the functions. So now I'm not going to trigger anything because I'm just going to deal with the sensors. So I'm just removing the function, and I obviously don't need add even detect as well because I'm not going to deal with any other inbuilt functions. So set warnings, you can able to make it for everything. Now ultrasonic sensor. So ultrasonic sensor is having a two kind of pins. One is trigger, another one is echo, ground, VCC. So in ultrasonic sensor we'll get total four pins. In that, ground and VCC are we used to connect with 5 volt and ground, so that's a different. Trigger and echo. So trigger will act like a transmitter and echo will act like a receiver. So now what I'm just going to do here is GPIO. So that's nothing but your GPIO underscore trigger. So that's nothing but your input output for the trigger is going to connect with 11. And this GPIO echo. So echo, it's nothing but the receiver from your ultrasonic. It's going to connect with the 18. Okay. So now in this setup, so again in this setup, we need to tell what are input and what are output. So now my trigger, so GPIO underscore trigger, so that's nothing but variable name only. So this trigger, that's nothing but 11th pin, that is nothing but my output. Okay, so 11th pin is my output, so I am just giving an out. So the next thing is I'm just copying the same line. So now echo, so we write it for trigger and now I need to write it for echo. Okay, so for this echo I'm just going to give in. Okay, so echo pin is for input. So this is a setup. So setup, that is nothing but I am just setting up what are the input files, what are the input pins and what are the output pins. After I set up the things, I need to tell output. Okay, so output is more mainly we used to handle with the help of trigger only. So instead of setup, I need to give output. So initial stage, I want to make output as a low only. So I need to write the condition like this. So in this low, I am just making my time to sleep for 2 seconds. So this is all optional only. So making a sleep, it's all up to you guys. If you want to give some gap, you can use a sleep, otherwise no problem. So then low, then what I'm just going to do here is high. So that's nothing but 2 seconds. If it's not receiving anything, then next to 2 seconds, it will send something and it will start to receive. So those kind of things I am just dealing here. Now I am making one while loop. So in a while loop, what I am just telling is the general purpose input, that's nothing but my echo. Excuse me. So my general purpose, it's getting my echo. So is equal to 1. Okay, if my input echo is equal to 1 means some variable name, what I'm just giving here is time dot time. So that's nothing but if my input is high, I am just getting the time. So the time is nothing but if my ultrasonic sensor is receive some distance. Okay, if it's detecting something and if it's receiving some value means I'm just dealing that time. I'm just getting the time here. Okay, so after this, what I'm just going to do here is I'm just going to apply some calculation for my ultrasonic sensor. So this is nothing but some variable name I am declaring. Ultrasonic sorry, pulse duration. So this is nothing but the normal duration I am giving. So the next thing is variable name x. So that's nothing but which I given for time. Okay, so minus start underscore time. So what it will do is the time when my trigger is started. Okay, when my trigger is started, that's nothing but once I switched on my Raspberry Pi, that's where my trigger is started. So the start time minus x minus start time, that's nothing but, for example, I started my Raspberry Pi by 7:35. So 7:35, and my GPIO pin receives some signal. Okay, so while GPIO input is receiving some signal is equal to 1, that's nothing but if receives some signal, that time only we are getting. Okay, so my ultrasonic sensor is receiving signal by 740. Now 740 minus 735, so pulse duration is 5 minutes. So after I switched on my Raspberry Pi, after 5 minutes, I will be just getting the things. Okay, now I need to apply the formula for distance. So this distance formula is the default formula which we will be applying with our ultrasonic sensor. So D equal to round off. So round off is nothing but an inbuilt function which is used to round the things. And pulse duration, that's nothing but my variable name which I calculated the time into the constant value. So the constant value for here is 17150 comma 2. So after I'm doing 2, that's nothing but 2 digits. I want to get the output in a 2 digits, that's why this 2, otherwise it's optional. Okay, so it will give a rounded value, that's it. Now what I'm just going to do is I want to print the distance comma D like this. And the final thing what we used to do is GPIO dot cleanup. Okay, so cleanup means it will act like a return zero in your variable name. So it is a kind of return zero in your C program. Okay, it's a kind of return zero in your C program. So that's the thing. So when we are just handling the things, okay, so when we are just getting this handling the things, when we are running this program, what it will do is it will get the default time of your Raspberry Pi which is started, and when it's run, so it will apply the minus, it will apply the subtraction, then you will get that duration calculation, so we can able to achieve the distance. Okay, so when we are just simply going ahead with this program, you can simply setting up that input output, and you are just setting up the low high. So when you are getting the high means when you are receiving some signal, so it will be start to apply that date time, then it will be just giving your start time, then applying with the distance, you will be getting your distance. So cleanup, which is exactly at return 0, so it will go to the initial stage. So when you want to handle any kind of sensor, now if you want to handle a motion detector sensor in your Raspberry Pi, the same kind of setup, and you need to set up the output, then you need to write the logics, then you need to apply the formula, then it will works fine. Start underscore time is an inbuilt function of Raspberry Pi board, so there is no need of declaring that. It will works fine when you are executing in Raspberry Pi. Okay. So when you want to connect your Raspberry Pi along with the sensor, this all the steps. Okay. So we need to connect your sensors with the Raspberry Pi general purpose input output only. That's it. And when you want to handle the camera kind of things in a Raspberry Pi, you need to handle with the help of OpenCV or MATLAB, those kind of image analytics library only. You can't able to handle with only basic GPIO. We do need a GPIO, but you can't simply handle with only GPIO. To handle a camera peripherals, you need to deal with OpenCV kind of libraries. So when you are going for your Raspberry Pi, the main reason for we are switching to Raspberry Pi is to run your AI concepts easier. So when you are going ahead with the normal system, so even in this system, if I am running my AI, it will be take around 2 to 3 hours to complete 10,000 data. But the same, if I am running in my Raspberry Pi, it do take the same time only. But when we are going for the advanced level, connecting your Raspberry Pi with the cloud, and in that when I'm running the data, the run speed of my Raspberry Pi is little higher comparatively to the basic the normal system. So for that perspective only, we used to prefer Raspberry Pi and cloud kind of things together. So it's all works fine. The another important thing is, when I am just going ahead with your Raspberry Pi, I can able to handle any kind of framework. So in Python, you can easily handle the frameworks when you are going for Flask or when you are going for Django, those kind of things. So handling the API again easier in Raspberry Pi. So how to handle the API will be our next session. So as of now, just to understand the advantages of Raspberry Pi. So Raspberry Pi is easier, more easier than anything else when you are going for handling your APIs. The reason being is, I will give one more small example for your Raspberry Pi, how it will be easier when you are just going ahead with the next thing. So this is one program. This program is for networking. Okay. So I hope you guys may aware of TCP connection and the networking and all those things. See, when I am running the same thing with the two different Raspberry Pi, okay, so how this will works, no? I can able to send the data from one Raspberry Pi to another Raspberry Pi. Okay, so usually when we are just going ahead with sending and receiving the data, sending and receiving the Raspberry Pi datas, it will works like a VPN, okay, virtual private network. So when two Raspberry Pis are connected to each other with the help of IP address, okay, so we used it to connect two Raspberry Pis with the help of IP address. So for example, here what we are actually doing is, first I am importing one TCP client and I am importing the time. So then I'm just setting up my IP address and my IP port number. So IP port number, it's all up to you guys. Then I'm just defining one function. So in this function, we are passing two arguments and state equal to connecting. So the state is a variable name. That's actually not a variable name. It's an argument name. So argument is defined here. So this on state, if it's received, this argument means, this argument, if it's received like connecting, means my Python will print waiting for connection like this. Else if I will get connection established, else if it's disconnected means connection lost. And then if I got any message means I will get client received data like this. See what this will what this program is doing means, it is actually making two Raspberry Pi to chat each other. Okay, so there is one chat Raspberry Pi. So this is on client 2. Client 1 also, we used to write the program. The same time when I am connecting to virtual network. Okay, so when I am connecting the same time, when I am connecting two Raspberry Pi parallelly, and when I am running this file, I can able to establish the connection between two Raspberry Pi, and I can able to make two Raspberry Pi to interact with each other. Okay. Yes, IP port is having some limitations. So you can't able to use n number of IP port in one program. One program you can able to deal with only one port. So if one program is running in the particular port means, you can't able to run another program the same time to the particular port. So for example, now I am running my Django server in 800, and if I want to run another server in 800 while my Django is running, I could not able to run it. But once my Django stopped, I want to run another server in the same port, I can able to run. So you can able to run a multiple servers in the same port but not the same time. So in that scenario, we can tell your IP port has having some limitations. So then again, this TCP client. So this TCP client, I'm just giving a two or three arguments. One is IP address. That's nothing but my IP address. Then my port number. Then on state change. Either it's changed or not. I'm just giving this arguments. So if my client is connected, so if I want to make my client to connect means, I need to make one more server to run the same time in different machine. I'm not supposed to run in the same machine. I need to run it in a different machine. So when I am running in a two different machines, then only we can able to achieve the things. So client dot connect. So when I'm just giving a client dot connect, so if my client is connected, okay, so if it's true means if my client is connected, I'm just going to send some message. Otherwise, I will get client connection failed like this. So this is one client output. So the same when I am just going ahead with the other thing means. So if I want to deal with one more server. So for example, this is your client server one. Okay, this is data client one. Okay, so let me show you one more client. Okay, so that's your data client two. Uh, yeah. So in this, what I'm just having is I'm having a threading. So threading, which is mainly used for multi-threading and socket and then time. And then I'm just making, by default, I'm making this variable name as a false. So this is mainly used for debugging. So now this is act like a receiver. So when this is acting like a receiver, we are using a class function. So of course, when we are going for threading based thing, we will definitely use a class. Threading, Django, augmented reality, this kind of concept will never comes without class. So we need to go ahead with classes when you are going ahead with your receiver kind of things. Okay, so that's the very first thing. So the next thing is I'm having one function. So in this function, what I'm just giving here is it's a complete debugging thing. Okay, so this is only to handle your error. So if there is any error means I'm just going to deal with this error. So the next thing is when I am going ahead with the next function, what I'm just going to deal here is buffer size. This is nothing but how much bytes I want to share. So that's a kind of thing which I'm defining here. Then data, I'm just right now I'm just making as an empty string. So now when I am just going ahead with while data, the indexing is not equal to the zero. So if my end message is not having anything, okay, so I will be just going ahead with the things. So my socket will initiate the buffer. So after this I will be just getting how much length. So this all Python inbuilt function. So how much length my client send it to me. So if it's not there, then I will be just getting the data is received. So if there is any error, it will just check the length and it will try and it will apply, it will handle the errors. Otherwise, I will simply go with the data received. So the next thing is again, I will be just going ahead with the connection part. So this is a complete connection part. So first I am just telling one person needs to act like a sender, another person needs to act like a receiver. So now this is a receiver and I'm starting the receiver. Then I'm just sending my command. After I'm sending this command, so this command may be anything. So the command may be given by the command prompt. So once I'm just sending the things, I'm just closing the connection. After I close the connection, it will be just actually completely closing my socket. That's nothing but it's completely closing my IP address itself. So this function which is used to make the initial connection. Okay, so when you want to initiate the connections, we can simply go ahead with this socket and your socket stream and your IP address of the socket, everything. So this is actually used to make the connection for your client and your server. So this is the initial file which we used to run. So after this, I'm just going to deal with only the connection. So other if some command is sent, it will run. Otherwise, it won't run. So when I am running this client and server, the previous file and this file in one Raspberry Pi and the same kind of file in another Raspberry Pi, it will make it will send the command between two boards. So I can able to make to work two boards to work each other. So that's the concept. So when we are simply going ahead with Raspberry Pi, we can able to make the Raspberry Pi as a VPN, so virtual private network, so it will works fine. So that's the concept here. Okay. So any other questions or any other doubt, guys? I know this kind of programs only you can able to understand how to write the program. The reason being is we need the complete server setup. You need two Raspberry Pi and we need two monitors, and then we need one file needs to run in one Raspberry Pi and another file needs to run in another Raspberry Pi. When you are just running this Python code, so it will make two Raspberry Pi to initiate the connection and you can able to handle the things. But as we are discussing the basic overviews, you guys needs to simply analyze how it's working. It's a kind of visualization thing only we can able to achieve. Even when you are going for simulation as well, we can able to just make the connection kind of things only we can able to make. But when it comes to the server to talk with each other, even with the simulation we could not able to achieve. Okay. See, connecting cloud things speak kind of things only your last session. Okay, that's having a different kind of steps. That's what your next session is, connecting with the cloud. Okay. But when you are just going ahead with any cloud, I'm not sure that we are going to do with ThinkSpeak or AWS. So if I get the credentials for AWS, we'll go for AWS. Otherwise, we'll go for a ThinkSpeak itself. But whatever cloud we are discussing now, that is actually common for all kind of things. You can able to deal with anything. So if you are developing something in some IoT product with the AWS, and now you want to connect with Google Cloud or you want to go for Azure, steps are same, the coding also almost same, but the some kind of credentials used to be different. Okay. So how this credentials used to be different and how we can able to how it's exactly different. To get that idea, now I will share you one more code. So the code is sending an email from Python. That is also useful for us. I will tell how it useful. Where you are just executing something, so it may be a kind of sensor value reading or those kind of things. So once you read the sensor value, you need to send the notification about the sensor value to some person, or you want to send the notification to something else. So those kind of communicating, so we need some protocols. So those kind of protocol establishment also be important here. So the protocol establishment and this cloud connectivity almost having a similar steps only. So let's we discuss now how to send an email by using Python. So that's also useful for us IoT. The reason is the same kind of step you can able to send a push notification also. In that first day session we saw one video, so where some mechanic come, they got a push notification. So those kind of push notification, getting the push notification kind of things, sending an email, sending an SMS, everything is having a same similar kind of step only. Okay. So any other questions? Guys, kindly fill out that attendance. We'll move to the next after that. Okay, I guess you guys done with that attendance. Let's we start with this sending an email. So this code is common for all kind of application. Okay, so even if you're making some kind of notification with the help of Raspberry Pi, or with the help of Banana Pi, or if with the help of web application, mobile, whatever it's up, this is actually common. Okay. So when it comes to Gmail, so Gmail, that is nothing but the Google Mail. Okay, so smtp.gmail.com. So this is a kind of provider which you need to use. Okay, so first I will tell. See, SMTP, that is nothing but a simple mail transfer protocol. Okay, so I hope you guys may aware of basic networking. Okay, so now you may get the doubt of why we need networking for IoT, because see, we can able to develop the things, that is a different stuff. Okay, developing is totally different. Okay, so when you were just going ahead with your development part, so we used to get your we used to get code, and then your circuit. We used to get all those things. Okay. So once I did the thing, now I want to make a connection means I want to send one thing to another thing, making a communication between each other, correct? So for that perspective we need a networking. Okay, so this protocol is a kind of rules, okay, which is going to make exchange, or it is used to make the communication between two process or two structure or two designs. So it's going to make something like this. Okay, so that's what protocol is. So in this example, we are going to discuss about the protocol called Simple Mail Transfer Protocol. Okay. So this SMTP is mainly used to send email. Okay. So this is for email only. Okay. So in your IoT, we have one more protocol that's nothing but MQTT protocol. Okay, so that MQTT protocol is another protocol which is used to make connections for the networking based connection establishment, and connecting the things to each other. We used to go ahead with this MQTT protocol. So MQ telemetry transport. Okay. So what this telemetry transport will do now, it will make publish, subscribe, those kind of pattern it will make when you are going for M2M communication. M2M means machine to machine communication. That's what M2M communication is. Okay. So to handle those kind of protocols also, we need the same kind of steps. So what are the steps means? First you need to get the provider. Okay, so from which provider I need to handle the thing. So then I need to get the port number. Okay, provider port number, this two thing is very very important. Okay, so in this mail transfer protocol I am going to deal with Gmail. So Gmail, the reason I chosen is it's free to use, and apart from Hotmail, Yahoo, these three things are free to use. This AT&T, Comcast, this all actually free to use only, but we have a paid version as well. When it comes to your push notification, we used to handle some APIs. Okay, we have a lot of APIs and we have a lot of protocols for that. But which API you are choosing, from that API, you need to get this provider as well. So after you get the provider, so for example, now I want to deal with Google. So when I'm going ahead with Google, I will be choosing smtp.gmail.com. Okay. So after I chosen this all the script. So import SMTP lib. That's nothing but a simple mail transfer protocol lib. That is nothing but the library. Okay. So when I am just going ahead with this way, this is a variable name and smtp lib.smtp. So again, in Python, everything is an inbuilt function. So this SMTP is an inbuilt function of SMTP lib. If you guys know Python, then only you can able to understand the scripts. I hope you guys already have your training in Python. So I hope you guys can able to understand this. SMTP lib.smtp, then I am passing a two arguments. Argument one, this smtp.gmail.com, this is nothing but I am telling my transfer protocol from which server I need to access. So I am telling this SMTP, I am going to handle the Gmail. So 587, this is a port number. If you are going for a Google, just to search for port number for Gmail. So you will get this 587 for TLS, I think 48 something for SSL. Okay. TLS is that freer version. Okay. SSL we need to pay. So for that perspective only, we are going ahead with the TLS. SSL we need to pay. So for SSL, we will get the different port number. That's that one and only difference. Apart from steps are same. So you guys don't need to worry too much about this. So this variable name dot start TLS, that's nothing but I am starting my TLS service, then login. Now, after I given this login, what will happen? No, my Python will log in to my Gmail. Okay, I repeat, my Python will log in to my Gmail. So this is my, you need to give your email ID and you need to give your password. Okay, so when you are giving your email ID and your password, your Python will get login to this email ID and password. After this send mail. So send mail, that is nothing but where you are going to send your mail. From, you need to give your email ID, whatever you are given, then you need to give two email ID subject. So in the subject tab, we will get the subject \n, that is nothing but new tab. Okay, it will go for a new line. And in subject, this is kind of some subject and we are just quitting the things. So that's it. So when I am going for any kind of protocol handling method, I need to first to know what are the service providers that's actually available for protocols. And then I need to know what are the port numbers, if port number is needed, because for MQTT, we don't need a port. Of course, we need a port number there also. Okay. Even for MQTT, we need a port number. We have a two kind of ports there. For SSL, we have one, and for TLS, we have one. So SSL means that is a secure server certificate we used to tell. Okay. So SSL full form is secure sockets layer. See, when you are going for a normal web application or website, if the website comes with the locked symbol, that is all your secured website. Okay, so you can able to give your personal details like your credit card, debit card, those kind of details we can able to give to that give to that website. But when you are going for other things, something no secure kind of things, that's all not SSL. Okay, so we are not supposed to give any kind of personal details to that website. So the same, when you are handling your protocols, we have a two kind of things, the same SSL, TLS. So SSL mostly comes with paid version, TLS only free to use. Okay, so when you are just going for SSL, mostly it's a server certificate kind of things. So there also, even if you are going to handle the MQTT protocol or some other protocols, we will get two ports for TLS1 and for SSL1. The same for mail transfer protocol only, we are having a TLS and for SSL. So we do have these two kind of things. Okay. So the same for connecting a cloud, that is totally different steps we need to handle, but we need to get some kind of details from the cloud. So those all I will explain later. So simply I'm just trying to explain the steps to handle the protocols. Okay. Simple mail transfer protocol we did. So now here, this protocol is the concept of networking. Okay. So when I am initiating the communication, when I am just going ahead with the communication, initiating and the connecting and all those things, we definitely need to go ahead with networking concepts as well. Okay. So that's all the concept that you guys needs to remember when you are dealing with the IoT, because IoT means it's not only about only the circuits and only the coding, it's about protocols, networking, Linux, hacking is another important thing which will participate in your IoT. So without hacking, you can't able to be completely develop on full IoT system. So hacking also very important for IoT. For hacking, obviously networking is the basic thing, and Linux also very important. So this are all the things that you guys needs to understand before you are starting the things. Okay. So now let me give a one small introduction about MQTT, because we are not sure about whether we are going to deal with MQTT. Like MQTT dealing are little bit advanced concept, very advanced concept. Okay. Uh, Facebook is using MQTT. Okay. For messenger application, actually Facebook is using an MQTT. Okay. Not only for your conversation. Okay, so I am sending you one message in messenger and you are receiving, and again you are just doing. Okay, but how this Facebook is using MQTT is, see, your protocol, it conserve your battery power as well. Okay, so I am calling you through the Facebook messenger. Okay, so my battery power is going to be reduced. Okay, so when I am going ahead, when I am enabling this protocols, what it will do is, it will make inconsistent of connection. Okay, so what it will do is, it will reduce some inconsistency. Okay, so due to that reducing the inconsistency, my battery power, it won't be that much weak. So for those kind of things, the MQTT protocol is used by Facebook. Okay, so and apart from this MQTT, so if this is an MQTT protocol, means you can able to connect this MQTT protocol with all other things. So this is the main server of MQTT protocol. So I can able to connect this with transport, and I can able to connect this with the IT sectors, and I can able to connect this with power plant. So like this, I can able to connect this different things. Major cloud services like AWS, Google, IBM, Azure, everything, all web service, it must support MQTT. If you are going for the low level cloud servers, so in India we do have some low level cloud servers. If you are going for the low level cloud servers only, the MQTT will not be supported for us. Okay, so when you are going for a real time analytics, monitoring the environment, mainly for smart homes. Okay, for smart homes, healthcare, logistics, it's all actually MQTT is very important one. So 75 percentage of IoT products are actually using MQTT. Okay, so this MQTT is enabling send, receive, publish. So send means I am sending one information about the home to your uh, mobile in the push notification. So that's what receive is. Okay, so then saving means that information which I am saving in my cloud. So for this kind of communication, we need this protocol. Okay, so apart from MQTT, we have COAP. Okay, then AMQP, Advanced Message Queuing Protocol. This AMQP is mainly used for communication purpose only. And then STOMP, it's another protocol. And then Mosquito. So Mosquito is nothing but exactly open source of MQTT. So MQTT needs to pay something, but we have an open source as well. But the complete open source for MQTT is Mosquito. So we can't tell Mosquito and MQTT both are different, both are same only. Then we do have a simple media control protocol, and then we have a SSI. SSI is mainly used for sensors, simple sensor interface. Then DDS are data distribution services. So this data distribution service is mainly used as a middleware. So sending and receiving the things, that's all your data distribution services. Okay, so this are some other protocols. So protocol is very important, and apart from making a client and a server communication is important. So mainly those kind of networking, security, machine to machine communication, those kind of purpose, we mostly prefer Raspberry Pi instead of Arduino, only to process your sensor values. So only to process your sensor values, we will go ahead with normal microcontroller board like Arduino, Node MCU, those kind of things. But to make a communication, to make the interaction, to handle the sensor signal along with that machine to machine communication, we need to definitely go ahead with the Raspberry Pi or some kind of boards like this. Okay, so this is a basic introduction of your Raspberry Pi. So I guess you guys have only visualization idea, because Raspberry Pi is a kind of thing where you need to have the complete lab setup to understand how the Raspberry Pi is working. If you guys really interested, I will recommend you guys to go ahead with Raspberry Pi board, and then sensors, LED, and then monitor, keyboard. You need to set up all the basic environment for Raspberry Pi. Then if you are running the Python code, not only Python code, you can go with JavaScript, you can go with whatever you want, you can able to go ahead with. So if you are going with all those things now, that could be much better to understand Raspberry Pi. Okay. Protocols are mainly handled with Raspberry Pi only. Not only Raspberry Pi, the kind of boards like a Raspberry Pi we can handle. Normal Arduino we can handle, but the compatibility and the speed is not that much like our Raspberry Pi. So that's the reason we are not recommending normal controller to handle this kind of protocols. That's it. So you guys having any doubts or any questions? So machine to machine communicate only. I am telling about the MQTT protocol. Apart from MQTT protocol, you have a COP and AMP, all those things. But this MQTT is most used in machine to machine communication. MQTT is mainly used for only machine to machine communication. So if you want to go ahead with the complete free version of MQTT, you can go ahead with Mosquito. Super. So any other questions? Okay, guys. Then I guess we are good for today. So if next session we will be just to going to discuss about posting posting your Arduino readings to cloud. Okay. So that's what the next session is, and the API introduction. Okay. Okay. Guys. Then we'll see you in next session. Thank you all. Bye.